Okay, sorry about that. Messed up the recording the first time. We'll try it again. Okay, so earlier we discussed these three basic derivatives, right? The derivative of a constant is always zero. That's kind of nice, right? I mean, we like zeros because anything times zero is zero, so it makes our work a lot easier. And, if we have a function and then a constant in front of it, well, its derivative is that function's derivative times the constant. Remember how I kept saying just leave the constant on the side, right? Yeah, that's all it is. And then for this one, like I mean that's just most standard rule, right? Where it's n times x to n minus 1 to the power n minus 1, right? We've used that a lot. Okay, so those three are important because you'll see them. They're going to pop up in these next four. So this one that my mouse is on right now, sorry, that's called the sum rule. This is called the difference rule. And this is the product rule. You'll definitely need the product rule. And the quotient rule, this one is, in my opinion, the hardest derivative formula that you'll find in Calc 1 because it's like there's the most stuff going on and it kind of gets largest, expands out sometimes if your teacher's, a dick and gives you some really hard problem. It can get pretty big. But real quick before I start the problems, you'll actually like the sum and difference rule because you'll realize that it's really not much of a rule, but just a statement of linearity. And what I mean by that is it's nearly the exact same thing. Okay. And yeah, it's a lot more fun than these other ones. All right, well, let's just do the example now. All right, so let's say your homework was to find dy dx for number one. Right, you want to find that derivative. So you're like, oh, what do I use? Do I use the product rule? And then maybe you think you to use the product rule, and I say, yeah, that's okay, right? You could use the product rule, and there's secretly another way, but we'll do the product rule first. Now, dy dx, I'm just to say equals product rule. Okay, just to know that we are going to use the product rule. But first, before we use it, let's think about what f is and what g is, right? Because we do have f's and g's in this product rule formula. So we could say f is equal to 2x. We could say g is equal to 4x. And if f is equal to 2x, then f prime is equal to 2, and then g prime is equal to 4, right? So if we use the product rule, we could see that, what is it? It's just f, right? So f, we just write 2x, and then times g prime. Well, g prime is 4. Okay, then we're adding, right? Now we got to add. So, and let's think about what we're adding. We're adding g. So g prime, just g is 4x. And then f prime, right, is 2. Okay, well, what does that turn into? Well, this is 8x plus 8x, which is equal to 16x. And you're like, oh, well, that wasn't too bad. And you're right, that wasn't too bad. But what if I was to tell you there's an easier way, right? Sometimes the trick is not to, like, you'll see this in later calculus videos that I do. The trick is not just to try to find the first formula, but maybe to simplify your original problem into something that looks easier, so then you could use a even easier formula. Okay, so y is equal to 2x plus, what, not y is equal to 2x times 4x, right? Well, I think everyone here would agree that that is the same thing as 8x squared, right? And I think everyone here would also agree that dy dx is equal to, see, if that's 8x squared, it would be 16x. So look at that. I mean, wasn't that a lot simpler that I just did right there? I mean, all of that, right? So sometimes maybe you can just FOIL or factor or just do some sort of algebra trick, whatever it is, to get out of doing the product or the quotient rule. Because sometimes I tell you a lot, you're going to see you can actually just really use your algebra techniques to make your calculus easier. Yeah. But besides that, let's move on to the next one. and move all this junk somewhere else. Yeah. Okay. So put all that garbage over there. Okay. Real quick, I gotta just move one little thing here before we start the next problem. Okay. So this next problem, 3x divided by x squared plus 1. This one, I mean, maybe we could do a cool little, you know, algebra trick, right? But that'll be a little bit harder for this one, truthfully. So let's just do it using the quotient rule, right? So if we look at f, I usually like to pick f as the top one, right? I mean, they do pick f as the top one here, so I think let's call f 3x. Okay, let's call g x squared plus 1 because that's the bottom one. And then you'd see that f prime is equal to 3. And then you'd see that g prime is equal to 2x, right? I think that's the part that we would all agree upon. Now, the next part is where it gets confusing and where you got to do it this order. In fact, there's really, there's no negotiating this order, right? When I say that, you can't have it as like f prime times g prime minus gf, right? It always has to be g times f prime minus f g prime. And that's because there's a negative here. Like this is a forced negative upon us. When I say a forced negative, it's just, that's part of it. It's not a plus sign. You know, a plus sign means you could add a negative and it's kind of gives you a little bit more room to kind of play around with. But this negative sign, it's telling you it needs to be negative right here, okay? There's no negotiating that. All right, well, besides that, let's actually do the problem now. So g is the first one. So we get x squared plus 1 times f prime. What's f prime? Oh, f prime is 3. Okay. And then minus, what's the next one do we got? We got f. Right, we got f. Well, f is, I'm gonna write, I always write this giant bracket here just so like I could distribute that negative in later. It's a trick. Not a trick, it's a tip. It helps me. Okay, and f is 3x times g prime, which is 2x. And all of this is divided by g squared, and g squared is x squared plus 1 squared. Okay, so that's your answer actually, and if you're on a test and you know your teacher says you don't need to simplify things, I would just leave it like that. But for the sake of the video, we'll actually go one more step and try to simplify this as much as we can. Let's start with that 3 and x squared plus 1 term. I'm just going to factor that 3. 3x squared plus 3, right? And then everyone here can see that it's 3x plus 2, not 3x plus 2, it's 3x times 2x, which is 6x squared, right? So we get plus, nope, not plus, right? Negative. Because remember that negative's on the outside. 3x squared plus 3 minus 6x squared. And x squared plus 1, I'm going to leave that just like that for now. Okay? There's no reason to make it just large, right? And then, oh, what do we see here? We see that there's a 3x squared minus 6x squared. It's negative 3x squared plus 3 divided by x squared plus 1 squared. And then I think we could maybe go one step farther with it. So the top, like the numerator, has a 3 here and it has a 3 there. So what if we factor out a 3? Right? Maybe we factor out a negative 3. We get x squared minus 1 divided by x squared plus 1 squared. And that is equal to, of course, dy dx. So that's your final answer. I mean, that's the nicest it can look, really. It's an x squared minus 1, and it's x squared plus 1 on the bottom. You cannot cancel those. Okay. Oops. Let me just move that to the side. Okay, what's our next one? Okay, our next problem is, oh, so this is like, kind of like that trick that I said we can do again. Is it a product rule, or can we do a little bit algebra to make it into a sum rule? I think maybe we should do a little bit of algebra to make it into a sum rule. So I purposely put this problem right here because I want to show you guys again, like I said, maybe if you just do a little bit of algebra, you can use the easier thing instead of the product or quotient rule. And we'll see that right now. Okay, so I'm going to rewrite this problem, right? I'm going to factor in the 2x squared, the 2x. So it's going to turn into 2x cubed, right? Plus 6x squared. Okay. Nope. It's not 6x squared, it's just 6x, right? Okay, so we want to know the derivative of that thing. I think we should, like I said, use the sum rule, where the sum rule is just basically saying take the derivative of each one of those things. So if we just say f is equal to 2x cubed, and we say g is equal to 6x, and then we want to use that rule. Oh, let me move this somewhere better. Yeah, let's just use that nice little formula, the sum rule. So, no, 1 second, sorry, I always mess up there. G prime is equal to what? Well, f prime, oh, let's find f prime here first. F prime is what? 6x squared, and g prime is 6. Oh my god, look at that, it's just 6x squared plus 6. And then if you really want to be fancy, you could write it like that. Right? That's the answer. I mean, that's really all there was to it, right? I mean, like I said, just a little bit of algebra can make your life easier. Well, that's all I really got for this video. We'll go over more complicated examples later on, because these can get harder.